Dear students, welcome back to the discussion on refrigeration and air conditioning. So, in the last session, we studied how to represent our vapor compression refrigeration system on a TS diagram and PV/pH diagram. Then we studied how to find out the various performance factors involved in the standard vapor compression refrigeration system. In this session, let us move on to a small problem on our vapor compression refrigeration system. So let us read the question. A standard VCRs developing 50 kilowatt of refrigeration uses the refrigerant R22 and operates with a condensing temperature 35 degrees Celsius and an evaporating temperature minus 10 degrees Celsius. Find 1. Refrigeration effect in kilojoules per kilogram. 2. Circulation rate of the refrigerant in kilogram per second. 3. Power required by the compressor in kilowatt. 4th one, COP. 5th one, power per kilowatt of refrigeration. In this question it is given, take Cp of vapor at 35 degrees Celsius as 0.96 kilojoules per kilogram Kelvin. Okay, so now we have read the question. Now let us try to solve this question. Okay, so before that, before we move on to our solution, first of all, the systematic way to approach a problem in our refrigeration and air conditioning subject is, first of all, try to draw a meaningful thermodynamic diagram connected with that question. So here we are dealing with a standard VCRs, okay, or standard vapor compression refrigeration system. So we have already studied how to represent the standard vapor compression refrigeration system on a TS diagram as well as in pressure enthalpy diagram. Okay, so here it is that. So we can first of all draw the TS diagram. We can draw the vapor dome. Okay, so we can start with the refrigeration step. 4 to 1, it will be a constant pressure heat absorption step. So the constant pressure, even though it is a constant pressure process, it will be appearing like a constant temperature process because it is happening inside the vapor dome. So 4 to 1 is this line. Then followed by our isentropic compression process, which is a vertical line in the TS diagram. Okay, then followed by our constant pressure heat rejection process 2-3. Then followed by the isenthalpic or constant enthalpy expansion process 3 to 4. Okay, so the same case we can draw the cycle in pH diagram, pressure enthalpy diagram. First of all, we can draw the vapor dome. Okay, then we can represent the refrigeration step, which is the constant pressure heat absorption step 4 to 1 process. Then followed by 1 to 2, it is our constant entropy compression process 1 to 2. Then followed by constant pressure heat rejection process 2 to 3. Constant pressure heat rejection process. Okay, so then followed by the constant enthalpy expansion process 3 to 4. Okay, 3 to 4 was our isenthalpic expansion process or our throttling process. Okay, so now let us again read the question and try to mark the given data on our thermodynamic diagrams. So first of all, a standard VCRs developing 50 kilowatt of refrigeration. So what is meant by this 50 kilowatt of refrigeration? We know that it is the refrigeration effect. So the refrigeration effect itself is given in a straight away. It is given like 50 kilowatt. But what is this refrigeration effect, or where is this refrigeration effect happening? During 4 to 1. During 4 to 1. Okay, so it is happening during the process 4 to 1, And so how we can represent this refrigeration effect in a pH diagram or in terms of enthalpy, we have already studied. That is, it will be H1 minus H4. So when we analyze the when we tried to analyze the standard VCRs, we mentioned that we assumed a mass flow rate of the refrigerant as 1. But here always it may not be the case. So we are writing the term for mass flow rate also. So it is 50 kilowatt will be equal to m dot, that is mass flow rate of the refrigerant times H1 minus H4. So what how we can write this? 50 will be equal to m dot into H1 minus H4. Okay. So what is this H1? Enthalpy at 1. So what is this H1? H1 will be at enthalpy at 1. But what is the condition of the refrigerant at 1? It will be saturated vapor. So how we can write this value for H1? That will be Hg value. Okay, that is H stands for enthalpy, G stands for saturated vapor. Okay, so Hg value at minus 10 degrees Celsius. Okay, so how did I choose this as minus 10 degrees Celsius? So again we can read the question. It is using the refrigerant R22 and operates with a condensing temperature 35 degrees Celsius. Okay, so the condensing temperature, so where is this condensing happening? At 2-3. So here it is given in the question, condensing temperature is only 35 degrees Celsius, that is at a somewhat higher temperature than our room temperature. It is not that a very high temperature, but it is still a higher temperature than our room temperature only. So here 2-3 is our condensation step. So where we can mark this 35 degrees Celsius? So we can mark this 35 degrees Celsius as 2-3, that is temperature at the points 2- and 3. But why didn't we choose the temperature at 2? Because we already have studied temperature at 2 means it will be a superheated state. Okay, so the superheated state of a vapor will be normally a very high value. It will not be a nominal value as 35 degrees Celsius. So we can avoid the temperature at T2 and we can write instead of taking T2 as 35 degrees Celsius, we can choose T3 and T2 as T2 dash as 35 degrees Celsius. Then again we are reading the question, and an evaporating temperature minus 10 degrees Celsius. So where does this refrigerant evaporate? At the evaporator or the freezer compartment or the refrigerator compartment or at the evaporator. So where is this evaporator or the refrigerator or the freezer compartment? It is from 4 to 1. So the temperature at 4 and 1 we are taking it as minus 10 degrees Celsius. So that is why we are taking this as H1 as Hg value at minus 10 degrees Celsius. So how we can find this Hg value of this refrigerant R22? Okay, so for that we need to use the tables. We need to use or refer the tables for R22. So now let us move on to study how we can refer the tables for R22. Okay, for that we need to take our data book. So here I have given a screenshot of how we can use a refrigerant tables, refrigeration and air conditioning RAC data book. So here I am referring the refrigerant tables and charts including air conditioning data. Refrigerant tables and charts including air conditioning data. The author is CP Kodandaraman. So here n number of data books may be available in the bookstore, but here I am using the CP Kodandaraman data book. So why I am choosing this, I will be mentioning the advantages of using this data book in the course of time. Okay, so how we can refer the tables of R22? So straight away go to the contents page. Going to the contents page, if you look at the contents page, so we can see there are n number of tables. Okay, table 1 to for example up to 20, then there are various charts like that. Okay, then the associated page numbers are given. So if we closely observe, we can find a table 2. We can find a table 2 for R22, that is monochloro difluoromethane, CHClF2. CHClF2, that is the chemical formula for R22. This is our refrigerant. So by referring the page number, we can straight away go to that page. So let me take that page. So here this is the page number 3 in my data book. It is page number 3 for R22 or monochloro difluoromethane, CHClF2. That is our refrigerant in our question. Okay, so we need to find out what we need to find out. We need to find out H1, which is nothing but enthalpy of saturated vapor at minus 10 degrees Celsius, because point 1 is coming at saturated vapor state of the refrigerant. Okay, so when we look at the refrigerant tables for R22, that is at table 2, there are some columns marked with several values. So now let us read the column titles. First column is the temperature in degrees Celsius. Then the second column is the pressure in bar. Then the volume, the specific volume in meter cube per kilogram. Meter cube per kilogram means the volume by mass. So it will be the specific volume that they are mentioning. Then the fourth column is given for enthalpy, that is H values, and the units itself they are mentioning that it is kilojoules per kilogram. Okay, and the separate values for liquid state and vapor state, that is HF value and HG values are given. Then the next column is entropy, unit you can note kilojoules per kilogram Kelvin. Then separate values for liquid and vapor state, SF and SG are given. And the last column is the specific heat, and the unit is kilojoules per kilogram Kelvin. And again separately for liquid state and vapor state, liquid Cl and vapor Cg are given. So here we need to find out Hg value, enthalpy at vapor state and corresponding to minus 10 degrees Celsius temperature. So first of all, look at the first column, temperature column. Look up the minus 10 degrees Celsius value. Locate the row for minus 10 degrees Celsius value, and also we need to find out what is that Hg value, that is the enthalpy for saturated vapor state. Okay, so again we are looking up the data book. So this is the column for Hg value, that is the saturated vapor state, enthalpy corresponding to saturated vapor state of refrigerant R22. So we are coming down. So corresponding to minus 10 degrees Celsius, Hg value will be 401.07. Okay, the value is 401.07. But what is the unit? The unit is kilojoules per kilogram. Okay, so we are noting that down as 401.07 kilojoules per kilogram. Okay, so this is how we will be using our RIC data book by looking up the corresponding temperature and enthalpy or entropy or pressure terms like that. Okay, so again for substituting the value of H1, we have found out the value like this. Now we need to find out the value of H4. So H4. So again we are looking up the pressure enthalpy diagram. So what is that? H4. What is H4? It is nothing but H3, because it is a constant enthalpy process, 3 to 4. So what is this H4? Which will be nothing but H3. But what is this H3? H3, what is the state of refrigerant at point 3? It will be saturated liquid state. So HF value, F stands for fluid. It will be HF value at which temperature? So what is the temperature corresponding to 3? What is the temperature corresponding to 3 is 35 degrees Celsius. So HF value at 35 degrees Celsius we can easily find out. So HF value at 35 degrees Celsius. So we need to move on to 35 degrees Celsius. HF value corresponding to 35 degrees Celsius. correctly it is not given, we can interpolate. Okay, so we can continue later.